Hi everybody and welcome to the Advancing Analytics YouTube channel. In this video we're going to be looking at the ONNX runtime. If you're new to our channel, don't forget to hit subscribe. If you like the video, give it a thumbs up. And if you want to stay up to date with all our videos on Azure, Databricks, machine learning and data engineering, then be sure to hit a bell and get updated with all of our new content. So this video, as I say, is all about the ONNX runtime. ONNX is the Open Neural Network Exchange runtime, and basically what that gives you is the ability to take a model built in any language or on any framework, I say any, there's lots of frameworks, and get that encapsulated in a way that you can deploy into a different environment. So if you think about the multitude of different options you have for actually building out a machine learning model and getting it deployed, there is loads, okay? So you could be choosing to build in R or Python or another language. Then when you're in that language, there's a whole host of different frameworks. You could be building out a model in something like a shallow process like SKLearn or XGBoost. And then you could be looking at more deeper frameworks such as TensorFlow and Keras, PyTorch, CNTK, Theano, Caffe, the list goes on, right? And with each one of those, you sort of need a different deployment strategy. There are some kind of standard ones, such as pickling. And pickling gives you the ability to serialize your model into bytecode and then store that and then deserialize it. And that kind of works for a lot of things, but not for everything. So ONNX looks to kind of replace that process with a standard runtime that works in Python, in R, in .NET, in Java, in a whole load of different places. So that really simplifies the deployment process. And it also really simplifies the problem of interoperability, right? Well, I've worked with so many different teams, so this has been a massive problem. It's sort of rare in a lot of places that you have a development team who are really strong in Python and machine learning, right? They are really good typically at .NET, at Java, at front-end deployment and back-end deployment and actual development around those areas, okay? They're not particularly very good at machine learning. So we've seen particular people, customers who like to take a model built in Python and try and convert that into a different language so that it works in the place of their current development code. And that is really problematic. That can cause huge fluctuations in accuracy and can just be a nightmare, okay? So we don't want to do that. So the alternative is that you take your .NET application and then you also have this kind of little Python piece just running off in the side, and that's really running your machine learning models. And that's also problematic because who maintains that? Is it the developers who maintain that? Should they be responsible for that? It's all up in the air, right? So we want to try and break that down. And ONNX sort of does that, okay? ONNX gives you the ability to build your stuff in Python, but if your front-end code is all .NET, then you just use .NET. You just use the .NET NuGet package for ONNX. And so that's what we're going to look at. We're going to build a model in Python. We're going to run it in Python. We're going to run it in Python under the ONNX runtime. And then we're going to take that and we're going to run it in an ML.NET function. Okay, so let's actually have a look at that and let's go through some demos. Okay, so here we are back over at my desktop now. So now, as I say, what I want to do is go through kind of end-to-end example. Let's look at how we build a really simple basic model in Python. There are some real shortcuts happening inside this Python model, so don't use stuff that you see in here necessarily as best practice for anything, because there's not even test train splitting in here. We are literally just building a model based on all of our data. And we're then going to take that model and really package it up into an ONNX model, and then we'll get that running on .NET, and we'll go through the end-to-end solution, okay? So first thing to really mention is all of the code that's available inside this inside this repo is all up on our public GitHub. There's going to be a link down in the description below. You can go and download it all from there, get it spun up, have a play. If you have any issues, just drop us a comment and I'll get back to you. Right, so main things that we've got in here, okay? You've got some notebooks and you've got a basic Python model. So first thing I'm going to do is I'm just going to get a Jupyter Notebook session running, and then let's have a quick look at what we're working with. So I'm just going to open up an Anaconda prompt. I'm just going to go to Jupyter basically and get this running. So let me just change the directory here. And then let's get Jupyter running. Okay, so that'll open up a Jupyter Notebook. And then once we're in there, we'll have a look at some of the code that we're working with. Okay. And we'll let that open on the right window. Okay, so in here, let's have a look in house price, ONNX runtime. Where are these notebooks? Wrong location. Right, let's try that one again. Stop that one. Let's change directories. Back up a notch. Jupyter. Let's try that one again. Right, so once we're here. Right, we've got a notebooks bit here. Okay, so open up this training notebook. And what you'll find in here is, as I say, a very, very basic Python model. So let's just zoom this in a touch. Okay, and so what you have here, right, super basic stuff. We're just importing a couple of packages. We'll have a look at how we can do some stuff, I think, in this notebook with Pickle. But then I'm importing a couple of additional things. So I've got this scikit-learn to ONNX. And from there, I'm taking in the convert scikit-learn. And then I'm also pulling in the ONNX runtime. And okay, so this model, like all models, has some, has a whole load of categorical values, and those categorical values ahead of time I've just encoded. So I've encoded a sale condition as normal as 1 and a building type as 1, 2 to 5. Okay, so I've got these particular things. So what we're going to do is we're going to import some data. Let's start by running through some of this stuff. We're going to import a bit of data. All this data is available. It's based, I think this is the San Francisco house price data, but I'll add in a link to where you can download the data as well. And so what we're going to do is we're going to start building out a really basic linear model. So we're using scikit-learn to build this model out. It's nothing very complicated happening in here, right? So what we kind of have is a little bit of mapping. So we're doing a bit of mapping from those categorical values back now into our numerical values. And then I'm creating a training set called xtrain, which has got my year built, my living area, a number of fireplaces, the sale condition mapping, and the building type mapping, okay? These are 5 values picked kind of at random. This model sort of works. It's not very good, right? There's a whole load of stuff that you would want to do on top of this. Standardization, scaling, regularization, actually probably taking a log of the sale price. But for now, we'll just do the basic stuff to prove the point of how ONNX works. So I say we create a training set, and then we create a single vector here with the sales price for our training. I'm pulling in scikit's linear model with a linear regression model, and then we're basically just going to fit that model, okay? So our REGR, our regression model there has been fit. You'll see that went very quickly. And we're just going to pickle it out, okay? So this would be my standard kind of process if I was doing this without looking at ONNX. I would just pickle this model out, I would persist it, stick it in version control and get it deployed into a container that way. And now, can we open that one in here? You might be able to. Let's open it anyway. So that is the pickled version of our model. So you can see in here it's pulled in a few things like NumPy and our linear regression, and with that I should be able to just get some predictions out. Let's go back. So let's have a look with our model. Let's call predict on our training set. Again, I said this isn't a great model, it's not a great best practice, but it does prove the point, okay? And so here we get some values back. Now, what I can do is also just pass in some new values into this, yeah? I could say, well, actually, our property was built in 2002, and now our values change a little bit, or actually, this was built back in the 1700s, and we get a negative value there. Let's put that back to 2000, and we can see there, right? So apparently a very old building you get for free plus some money back. Again, not a great model, but it proves the point. Okay, so we have a model, right? We've got this idea of a model. Now what we want to do is we want to get that running in ONNX so that we don't need Python. We can use something else. So I'm going to set up a couple of, just a variable here of where I want my model to go to. A lot of this is heavily based around an example here. This example was really great at giving me the basis of what to work with, and a lot of the ONNX docs are pretty good. The ONNX docs for actually deploying into ML.NET, they're not so good, but for actually deploying inside Python, they're pretty good, and it gives you generally a pretty good idea. Right, so there's a couple of key things to really call out here. So let me zoom in and we'll cover some of these off. Okay, so first things, we need this thing, right? We need to know the number of features. If I remember how this tool works, there we go. We need to know number of features. How many features are going into the training of this model? We had 5. We had what? The age of the property, the living area, the number of fireplaces, the building condition, and the sale condition. And so with that, we create an initial type here. And that initial type is of a float tensor type for us, because it's all floats. If you had a couple of floats and then you had a couple of categoricals, then you could do the same thing here, right? And so we're pushing through this number of features here, which is our 5. Then we are calling this function here. So I'm then saying my ONNX model, call this convert underscore scikit-learn, SKLearn, taking in my model and passing in my initial types being my float tensor type. And so that's really setting up the ONNX model so that it can start working. It knows what it should be expecting to receive. It's kind of got the schema of what it's expecting. And then I am, in a very similar way, I'm just going to write that back out. And I am just going to use ONNX's serialize to string format. So I'm going to write that back out and actually store that. So can we open that one as well? Do you want to open it anyway? Sure thing. So that's what we end up with. So a slightly simpler looking model, right? And we've got our feature input here. That's a thing I should call out a bit better as well. Just so you know, we've named our initial input there feature input. You'll need to know that when you pass this off to something else, because it's going to be looking for that particular input. If you had multiple inputs, you could name them differently, and that would be fine. Right, what if we want to actually start scoring with this? So let's run this. Let's run them all. And let's have a quick look. Okay, so in ONNX, what you're going to do is create a session. And it's this session that you're going to use for scoring. So here I've got a session and I'm saying I want you to do an inference session on that particular path where that model lives. So this model has been created and put out, and it now is over here, and we're just instantiating a session based on that. I can then start pulling out a couple of inputs. So I can pull out, well, what's my input name and what's my output name? And with that, I can use that to then set up everything I need to get this scoring. Let's get rid of these bits. And then it's just this line down here that is responsible for actually doing any kind of predicting. So we're having to do a couple of things here. I'm saying session.run. So I'm running the session of that particular ONNX model. I'm saying I'm not interested, I don't have a label name, I'm not worrying about that, just worry about my input. So this expects 2 things. It expects your output and then your input. So I'm saying my output is none, don't worry about it, but my input is my xtrain.values, and I'm casting them as a type as a numpy float 32, and then just taking the first element from them, okay? So that is passing it into ONNX in a format that it's expecting, which is basically a series of floats, okay? And then I just print those predictions. And there we get, we get these values. If we have a little look back up in our notebook, we should be also able to see when we called predict, we got 219298 and we got 219298 again. Now, there's a slight precision loss here. We had 0.5 on here, and up at our top one, we had a 0.16. So a slightly different precision, but it's generally there, okay? It's pretty spot on with what we're trying to do. So, what if I wanted to run this with just a completely new value, similar to what we were doing before, right? So what I could do here is I could just say, well, I've got this array of values, and I can just run that. And maybe again, what I can do is change that to the year 2000, and I get a value. If we change it to 1700, I get that negative value again, right? Okay. So that is it running a Python model converted into ONNX and actually running inside Python. So this could be a great way for you to standardize how you're working and get everything running in Python in a really consistent way. So regardless of what packages you're using, just by converting it to ONNX, you know it will run. But that doesn't kind of solve how we could take this ONNX model and then run it in, say, something like .NET. So let's have a look at doing that now. So again, inside our repo, you'll find a whole load of stuff pointing to a ML.NET project, which uses an Azure Function. So if I open that one up, over here, we've got a couple of things. So you've got an Azure Function, and then you've got a very basic command line prompt as well. But it's a function that we're going to be looking at. So let's zoom this function in a little bit and talk through what's really happening. So this is a standard Azure function, not doing anything particularly fancy here. It's a HTTP trigger, assumption being here, we package this up as a function, just deploy it into Azure, get a REST API off the back of it, and we just call that, okay? So we've got it. I've called my function house price function. It's a really original name, thank you. And what we're doing here is ignoring some of the boilerplate stuff we've got here. Let's have a look. So with a function, what you do is you'll do a HTTP post with it. You'll post a little JSON object. You'll take the values of that JSON object, pass it through to your model, let ONNX do the scoring, produce your result, and then return that back to whatever was requesting it, your application, your website, whatever it is. So we take the request body, and then we take the data from it using this JSON convert. We deserialize the object, and we start pulling out a couple of key things. So I'm going to pull out the data, the year it was built, and then going to pull out the greater living area and a whole load of other bits and pieces, okay? So it's expecting to see a object which is at the top node, this thing model P, so my model parameters, and then each one of my parameters. And then passing in my ONNX path, so where the model exists. What I should do is actually host that locally and just do a reference to where that model is, rather than to where it actually is on my computer. Then what I want to do is start building out a very similar thing to what we had in Python. So first thing is we need to specify what our input tensor is. So once we have the idea what our input tensor, if you're unfamiliar with a tensor, just think of this as a matrix, okay? It's just like a table. It's just a wide table. You've got vectors, single columns, and you've got matrices, and a tensor is basically a matrix. A matrix is just a fancier way of saying a matrix or a table, okay? So we have a tensor, and we are defining that tensor as a dense tensor, which is an ONNX type, and then we're saying it's a float, and this new float is going to take in our year built, a living area, fireplace, sale condition, and building type, okay? And our tensor expects to see what's the incoming data, and then also what is its dimensionality. And its dimensionality is expecting that we are passing in an output and an input. So much like we saw with our Python example. So down here we were saying we had two inputs, right? We had our basically our output or our label, and then we had what our input was. The exact same thing is happening here. And so we've got five features going into our model. So what we have is we say we've got one output, which is our score that we're inferring, and then we've got 5 inputs. And then from that, what we want to do then is create this variable here called input, and I'm saying create myself a new list of ONNX values. And so that is then going to take this input tensor and shape it into a format that is going to be acceptable for our session to run. We then kick off a session. So again, very similar thing, new session on our path where we've got our model. And I'm just going to call same thing, right? Session.run on my input. And that will give me my score back. It gives you it in a quite deeply nested way. And which is why we kind of have this thing. Now, honestly, this took me an absolute age to get right. I tried a whole load of different things to eventually get back to my single result. And I think that's probably because you typically wouldn't want to work in this way. You'd be scoring over a batch, not just doing a single inference. I'm trying to do just a single inference, which is probably why it all got a little bit complicated. So I take my result, I take my output, which is from my session, I take it to an array, back to a tensor, back to an array, and then I pull the first value out, which is my score. I package that up as a result object, and then I just pass that back out to my function. Okay, so let's run that. So if I run this function, let's say it's an Azure function, it's going to kick off the function runtime. Get that going. So what you should be able to see here is once this gets going, this will start pulling up, right? This is an Azure function. I'm going to set up your environment. I'm going to look for all of your functions and then get a REST API locally spun up that you can start firing stuff against. It's kicking off. And it's saying here, all right, I found a house price function that you can do a get or a post to on this particular address here. So if you're looking to try and test this stuff, you're not familiar with functions or doing post requests, I always recommend this tool, which is Postman. And Postman gives you a really simple way that you can just post requests against an API. So here I'm using Postman. I've taken the address from the function runtime. So if we have a look here, I can just take that address there and stick it up in here. And now it's expecting a couple of things, okay? So I'm saying that I'm going to do pass through a body, I'm going to pass through raw, and that my type of data I'm passing through is a JSON object. Model P, which is those model parameters, the year built, the living area, and what I can do is just hit send, and that's going to send my request back off to my model, and then it's going to give me a score back. So over here, what we should do is start seeing that whirling away, and then I'll get a score back and we can work with it. And then we get a response back. So now if we change these values, we should start seeing these scores coming back. And now again, so this is now going through a model which was trained in Python and then has been converted into ONNX and is now being run on ML.NET. So the benefits that you have of doing this kind of approach is that what you don't need to worry about is what language people are building their models in. As long as they can convert it into an ONNX model, then you can run it. We just change where your model is expecting to be. We change the type that you're expecting to push through to it. If it's images, if it's numerical data, it doesn't really matter. And then with that, we can get that all deployed in a really nice, consistent way. So thanks everybody for making it to the end. Don't forget to like and subscribe, hit that bell so you don't miss another one of our videos, and I'll see you in the next one. All right, see you then.